Hello friends, welcome to Electronics for You. In this video, I will explain ultrasonic thickness measurement. So it is a topic of thickness measurement where we will use ultrasonic waves for the thickness measurement, and it is also known as UTM in short. Following topics will be covered in this video: non-destructive thickness measurement, construction types, working advantages and disadvantages, applications of ultrasonic thickness measurement, that is UTM. Along with that, we will cover one more topic, that is the couplant used in the UTM. So let us start with non-destructive thickness measurement. So as its name indicate, it is a non-destructive thickness measurement. So it is a method of thickness measurement in which we will not break the workpiece here. For example, if you want to measure the thickness of a pipe, and the pipe is of let us assume that it is a 50-meter long pipe. So in this case, you need not to break the pipe here, and you can directly measure the thickness by using some technique, and that's why it is known as non-destructive thickness measurement. In NDT, that is non-destructive thickness measurement, we use the beams of waves of short wavelength and high frequency transmitted from a small probe and detected by the same or other probes. Such waves can travel larger distances in fine-grained metal in form of divergent wave with the advanced attenuation. So we will use some ultrasonic waves here which will travel through the workpiece, and we can measure the thickness of that material by using advanced technique. Precision of wall thickness gauges can also be used to detect the damage caused by erosion and corrosion. So you can measure the erosion and corrosion in non-destructive thickness measurement. There are two types of NDTs available. The first one is ultrasonic thickness measurement, that is UTM. I will cover this topic in this video itself, and the next one will be electromagnetic acoustic transmitter, the transducer, which will be covered later. So let us start with the ultrasonic thickness measurement. Ultrasonic testing can be done to measure the almost any kind of material. So any kind of material can be used. The material may be of glass, plastic, metal, ceramics, fiberglass and composites, etc. Ultrasonic thickness measurement gauge mainly consisting of these two devices. The first one is gauge probe, and another one is the ultrasonic gauge meter. So this is ultrasonic gauge meter thickness. It is also known as ultrasonic thickness gauge, and this is the gauge probe which will produce the ultrasonic frequency here. Let us see it one by one. The first one is gauge probe. Ultrasonic gauge probe, here these are the piezoelectric sensors. So in the gauge probe, we use the piezoelectric sensor which produces the ultrasonic frequency here, and that sound waves is actually, you can see here, it images the sound wave into the material when excited. Choosing the right gauge and the transducer depends on the number of factors such as geometry, thickness, range, accuracy, requirements, temperature, and any specific condition that may exist. So any you can choose this gauge according to these different requirements. Generally, a fixed frequency is used for the gauge probe, but also we can use the tuning frequency whenever needed. The next one is the thickness gauge. This device is known as thickness gauge. So thickness gauge, as you can see here, it is connected via a cable to this gauge probe. Gauge probe just producing the ultrasonic frequency. Now its output is also connected here and through this cable, and this is connected to the ultrasonic thickness gauge. Now what will be as it is a gauge, or we can say that as it is a meter, it is used to measure the thickness. So whatever the output from the probe there, we will collect it, and we will see the change in the output here. In this case, we measure the time taken by the sound wave to transfers from the transducer through the material to back end into the workpiece and reflect back. So we use the reflected sound wave here to measure the thickness of a material. The ultrasonic thickness gauge then calculates the data based on the speed of sound. So we will set the speed of sound here, and further it can measure the thickness of the material. For that, some calculation needs to be done. Now, these ultrasonic thickness gauges are generally divided into two types. So, there are two types of thickness gauges. The first one is corrosion gauge and another one is the precision gauge. Now, let us see it one by one. The corrosion gauges are, as its name is corrosion gauges, they are used to measure the corrosion. They are used to measure the internal corrosion, or we can say that we can measure the loss of the material due to the internal corrosion by using the corrosion gauges. The next one is the precision gauges. As its name is precision gauges, they are extremely versatile and can measure the higher accuracy than the corrosion gauges. The accuracy of the precision gauges are high, and various techniques are used for the measurement here. In this case, let us consider an example of pipe again. So pipe will have some thickness here, and in this case the first one is this one. You connect here the workpiece, that is the gauge probe here, to this workpiece. Okay, some couplant is needed here. Now you can measure the thickness of this pipe like this. Okay, the next one is you can measure the thickness from this point to this point. Again, you can measure the thickness up to this point. So there are three different intervals. These are given here. You can read it and you can understand it. So these are the precision gauges. Now let us talk about the couplant. In this case, whenever we are using the probe, there may be a problem here. Some ultrasonic coating thickness gauges require the couplant to eliminate the gaps between the transducers and the test bed. So whatever the workpiece is there, there should not be any gap between the transducer and test piece. Therefore, this gap can be filled by using gel, paste, or moderately viscous format. Their use is necessary because sound energy in ultrasonic frequencies typically used for the NDT is not effectively transmitted through air. So sound energy here, that is ultrasonic sound, will not be transmitted effectively through air, and therefore it may create some problem, and you will get an inaccurate result from the due to this error, and therefore we use the couplant here. So various types of couplants can be used. You can use water, motor oil, grease, and even some commercial product like hair gel, but most common couplant is the propylene glycol. But apart from this, for specific, for example, if high temperature is there, so then some specially formulated couplants are available in the market. So these are the couplants. Now let us talk about the working of this UTM. We use the probe over the workpiece, and this gap is filled by the couplant, but one care should be taken that this surface area should be kept smooth. For that, you have to remove some corrosion if it is visible there. Then you have to remove some paints if exists there. Then you will apply then you can apply couplant here, and further it will measure the thickness by transmitting the sound energy here, and the sound energy will reflected back. Again, you can collect it with the help of probe, and further this time is measured, and thus you can say that it uses the pulse or echo. For that, the formula used is this one, that is T is equals to Vt divided by 2. Here T is the thickness of the workpiece, V is the velocity of sound of the test material, then T is the transverse time. Generally this transverse times is measured, and further it is connected to the meter there, and meter will convert it into the thickness. But one care should be taken, that is about the velocity of sound. We are using this V here, and the velocity of sound in test material changes as the material changes. So here is the different velocity of sound for the different materials. For example, for aluminum it is different, bricks, concrete, copper, and these are the different velocities. Again, these are having some range. Therefore, if you want to measure the thickness of material, then you need to calibrate it, and therefore calibration is very plays a very important role in the ultrasonic thickness measurement. Now let us see some advantages of this technique. It is a non-destructive technique, then high penetrating power, which allows the detection of loss deep in the part. It need to access only one surface. You will not require the second surface compulsorily. The detection of extremely small fault is also possible in UTM. So we can say that it is having good accuracy, and you can achieve this good accuracy by using the proper calibration technique. It is not hazardous to operator or any nearby person, because we are not using any gamma rays or X-rays here. It is capable of portable and highly automated operation, and quick results are obtained in UTM. So these are the advantages. Now let us talk about the disadvantages. It requires the calibration, as I already told, for every material. Parts that are rough, irregular in shape, very small or thin, or not homogeneous, are difficult to inspect, because you need a proper contact between the probe and the workpiece here. Also, you should remove the rust or paint here, and therefore you have to make the surface clean here. Couplant is required. This is again another disadvantage. The equipment can be expensive. So these are the disadvantages associated with the UTM. Now let's talk about the applications of UTM. It is used in different material testing industries. For example, electric power generation, production of steel, aluminum and titanium, then in fabrications of airplanes, jet engines manufacture, and ship building. So these are the applications of UTM.
And friends, if you like this video, please subscribe our channel and press the bell icon for notification. And like, comment and share. Thank you.